Hi and welcome to Kirti's Learning Factory. In today's video, we're going to learn a very interesting concept, which is finding the number of zeros, okay, in an expression. So that's what we are going to learn today. It could be, and when I say expression, basically what I mean is a number, okay, which will be expressed slightly differently. So it could be expressed as a factorial, okay, or it could be expressed as say a power of a number, okay, so n raised to the power something, right? So eventually it is a number and we have to find out the number of zeros in that number. Now what it means, what is the meaning of number of zeros? Number of zeros, so for example, let me give you a simple example, 589. What is the number of zeros in this? It is 0. Let's take another number, 509. What is the number of zeros in this? That is also 0. Now, you might argue that there is a 0 in the number, but in mathematical terms, this is not what it means. इसका मतलब ये होता है कि पीछे से, यानी कि right hand side, from the right hand side, how many zeros are there in the number? So for example, if the number were to be 590, the number of zeros in this number is 1. Yeah. If the number is 5900, the number of zeros in this number is 2. Now, you might also think that it's a very simple thing. I mean, if you have a number, you just count the number of zeros and you get it. You're absolutely right. But when these kind of questions are asked, so the expression is changed. So you will get expressions such as this. You will be asked a question that what is the number of zeros, in 127 factorial, or you will be asked what is the number of zeros in an expression 22 into 32 into 69 into 81, something like that. So eventually in these things, what you will have to do, normal method will be, is that you will find out the value. Here you will multiply everything, you will get the final number, right? And then you will count how many zeros are there, correct? That's the normal way of thinking. But will you be able to find out the number when it is given as a factorial of 127? Do you think you will be able to multiply 1 into 2 into 3 going up to 127? I don't think so. And therefore, this question is asked. So that is why this question is asked. Now let's get into what it means. Yeah, what it means. So for example, if there is 589, 5890, yeah, we can write this number as 589 into 10. So the number of zeros in any number is nothing but the number of tens in that number. How many tens are, what is the power of 10? What is the power of 10 in that number? Okay. That will give you the number of zeros. Now, if we further break it down, what is 10? 10 is equal to 5 into 2. So basically number of zeros, okay, number of zeros is nothing but number of fives, correct? Now, why not number of twos? Because see, 10 is constituted when you multiply it 2 into 5. Now in any number, you need a 5 and you need a 2. You need a 5 and you need it. So obviously you have to find this combination. But generally, if a number is expressed in form of a factorial, in those cases, you can say that the number of zeros is basically number of fives. Okay. Now let's go to the previous example only. So for example, let's take this one. Now here we have to find out what is the number of zero, correct? Let's see how can we go about this problem. So we have to basically find how many 2 into 5s are there in this expression. In here 22, when we break it down, it is 2 into 11. When 32 we break it down, it is 2 raised to the power 4. Sorry, it's 2 raised to the power 5. When 69 we break it down, it is 3 into 23. Okay. And when 89, we break it down, it is 3 raised to the power 3. So we have 2's, yeah, but we don't have 5's. And therefore, if we don't have 5's, we don't have 5 into 2. If we don't have 5 into 2, we don't have 10. If we don't have 10, we don't have a 0. So the number of zeros in this given example, okay, is 0. Now let's come to the other example, the example that we considered, say 127 factorial. Now this is something that you cannot even break down, right? And you have to find the number of zeros. And if it is expressed in a factorial form like this, then the number of zeros, as we have just read, the number of zeros is nothing but the number of 5's. Yeah, because see, 1 into 2 into 3 into 4 into 5. Okay, let's consider 5 factorial. To start, what is the number of 5 here? 1. What is the number of 2 here? It is 1 and 2 here. So number of 2's is 3. Number of 2's is 3. But number of 5's is 1. Therefore, as you move ahead, you will realize that number of 5 is the limiting factor. Whatever is the number of 5, the number of 2's will always be more than that. Which is why when we are to find 2 into 5, 5 will be the limiting factor, not 2. You will have plenty of 2's, but the limiting factor will be the number of 5's. Therefore, number of zeros is equal to number of 5's in the expression. Simple as that. Now, when we have to consider 127 factorial for that matter. So let's first understand that obviously, what will be the number of 5's? Correct? How many times 5 is coming? So if you divide 127 by 5, okay, whatever is the quotient or the greatest integer function, this quotient. But you understand that, say, 1 into 2 into 3 into 4 into 5. This is nice. Then you go into 6 into 7 into 8 into 9 into 10. Now you get another 5 here because it's 5 into 2. Then you go 11 into 12 into 13 into 14 into 15. You get another 5 here, right? Then you go 17 dot 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 into 20. You get one more 5 here. So 20 is 4 into. Then you go 21 into 22, 23, 24 into 25. You get 2 5's here. You get 2 5's here because it is 5 square. So we will have to count the additional 5's also, which is all the numbers wherever 5 is raised to a power, we will get an additional 5. So 1 5 here, 2, 3, 4, but here the number of 5's will it will jump by 2 because 25 is 5 raised to the power 2. So we will find out 127, whatever is the number divided by 5. See, if every 5 times, whatever is the quotient or the greatest integer function, it will give you the number of 5. So every 5 times this, it will get covered. But we also need to cover for how many times 25 is coming, because it is 25 is nothing raised to the power 5. 5 raised to the power 2. So there is an additional 5 here. Correct? And then we will go 127. 5 raised to the power 3 also will go because 5 raised to the power 3 is 125. It is just less than. So we will continue to divide this because the moment you go into 125, it is 5 into 5 into 5. So at this moment, you are not getting one additional 5, but you're getting 2 additional 5's. Correct? So 25. Therefore, this equation will give you all the numbers of 5. Beyond this, we don't need to go because we are only calculating up to 127 factorial. So whatever is the highest power of 5, just less than 127, that should do. Next, 125 into 5, then it will take us to 625, which is the next power. So we don't need to worry. Yeah. So 127 into 5, correct? So 127 by 5, the greatest integer function, it will give you a number of 25. This will give you a number of 5. This will give you a number of 1. So you will have 25 plus 5 plus 1, which is 31 zeros, right? That is the number of total number of zeros you will have in factorial 127. If you did not understand, just come back and think that how many times 5 has repeated. This 127 by 5, that quotient will give you that. How many times 25 has repeated? So it will come at 25, 50, 75, 100, and then 125, 5 times. That's what this number is, correct? So those additional 5s, because they will get counted here. And then how many times 5 raised to the power 3 has come before 127 factorial? So it will happen only once. At 125, you will get 5 raised to the power 3. So that one additional 5 will be here, because 125 we have also counted under 25, right? So 1 5 of, in 125 there are 3 5s. 1 5 we are counting here, 1 5 we are counting here, 1 5 we are counting. That's how we count the total number of 5s, and therefore the number of zeros in 127 factorial will be 31, and you can apply it to any other larger factorials also. So I hope you enjoyed the video, and if you did, then please keep coming back for such amazing content. Thank you so much.